Okay, so I said this was a calculator problem, problem number 4, but I actually did most of it without a calculator, and then at the very end I used a calculator. So I'm going to show you how I did it. There might be another way to do it, but I'm just going to show you my way. So this is a calculator problem, but I'm not going to use the calculator right away. Okay, the acceleration, A, meters per second squared, of a particle at time t is given by this function. Okay, so this is my acceleration function. The particle is at rest when t equals 1. So I know that the velocity when t is 1, the velocity at 1 second is equal to a speed of 0. So when it says at rest, that means the velocity. That means v of t is equal to 0. So when is v of t 0? When t is 1. So v of 1 is equal to 0. Okay, find the velocity of the particle when t equals 5. So the way that I looked at this is that I need to find the velocity function from the acceleration function. Well, acceleration is the derivative of velocity. So if I have acceleration and I want velocity, I have to go backwards. So that means I need to integrate. So I'm going to integrate 1 over t plus 3 sine 2t. And they gave me this. That's just because, well, you're going to see in a minute why they gave me this. So don't worry about the domain right now. So I just want to integrate this in respect to t. And I'm not going to put any numbers here because I'm not trying to find like a total distance. What I'm interested in finding is the velocity function, because once I have the velocity function, then I can change t to 5, and then I can figure out what is the velocity of the particle when it's when time is 5. Oh, you know what? I just realized we can do this a much easier way. I think there's a couple ways we can do this. So let me just try something real quick. I think that we can just put this in. So 1 divided by x, because we don't have a t, right? Plus 3 times sine of 2x. Okay, so if I graph that, thinking about it. Okay, and window, I'm going to go to standard window. Oops, sorry, what am I doing? Standard window. It says this equation is only good for t is greater than or equal to 1. So I'm only interested in this portion over here. Find the velocity of the particle when t is equal to 5. So, you know what? I've just changed my mind. I'd have to integrate this. No, never mind. I was going to try and do something on here, but now I've changed my mind. Okay, so we're going to integrate this. I don't have to worry about boundaries because I'm not trying to find any kind of area. What I am trying to find is I'm trying to find the v of t function. So, and I'm going to get that by integrating. So I'm going to break this up. I'm going to integrate 1 over t dt plus 3 sine 2t. I'm going to make them 2 separate functions. That's going to be easier for me. So I'm going to focus on this one first. I recognize this, but if you don't recognize it, you should be using your formula packet. So in my formula packet, when I have like 1 over x, see right there, that's equal to the natural log of x plus c. So this, when I integrate it, I get natural log of t plus c. I'm going to put the plus c over here because it's going to be plus c for the whole thing. And then the next one, I keep my constant, and then I have to integrate. I'm going to do this in 2 steps. I have sine 2t. Okay, since I have something in here, I need to think about my u substitution. So if I were to if I were to take the derivative of sine of 2t, I would get cosine 2t times 2, because we have to use the chain rule because I have something happening in here. So that means I'm missing a 2. So I need to put my 2 in here. So I'm going to slip in a 2 there. But if I put that there, I have to counteract it by putting a 1/2 out here. So this is my dt. This is like my du, my dt du? No, du dt. And this is like my u. Okay? So now when I integrate this, this whole thing is going to go away. So when I integrate sine, let's make sure we don't make a mistake. When I integrate sine, I get negative cosine. Okay, so this is still going to be natural log of t plus 3/2. This is just going to become negative cosine, so negative cosine of 2t. And then I have my plus c. Okay, so let me demonstrate. If I have negative cosine of 2t, say that's my y equals, then my dy dt, my derivative, dy dt, my derivative is going to be sine 2t times the derivative of that, which is times 2. Okay, so that would go right here. So that's why I needed that 2 in front there, because of the chain rule. Okay, I needed to put that in. Okay, so now I need to figure out what c is, because here's my velocity function. Here's my velocity function, but now I need to solve for t. So that's where this information comes in. I have a point on the graph when t is equal to 1, the velocity is equal to 0. So I know that the velocity is 0 when t is equal to 1. And now I'll be able to solve for, I'm going to move my negative sign out here, cosine 2 times 1 plus c. Now this is where I needed the calculator in order to solve for for c. I'm going to have to move these guys to the other side. So first of all, natural log of 1 is just 0. That's equal to 0. So, and then this one, when I move it to the other side, I get positive 3/2 cosine of 2. It's going to be equal to c, okay, because this is just 0. All right, so c is equal to 3 divided by 2 times cosine of 2. And so therefore I get c is approximately equal to negative 0.624. So now I can write my function, my velocity function, my whole velocity function. Move this out of the way, more space. So my actual v of t is going to be equal to this guy right here, but with the c tacked on. So natural log of t minus 3/2, because I'm moving the negative sign out here, negative 3/2 cosine 2t minus, I ran out of room, 0.625. So now we need to find when t is 5. So v of 5 is equal to natural log of 5 minus 3/2 cosine of 2 times 5 minus 0.625. So I can now do that on my calculator, or I could have put in the function and found the value when x is 5, but I'm just going to go ahead and type it in. So natural log of 5 minus 3 divided by 2 times cosine 10, close my parentheses, minus 0.625. And I get v of 5, the approximate velocity is approximately 2.24. 2.24 meters per second, right? Because we were in meters and seconds if we look back at the original problem. So there it is. Okay, maybe there was an easier way to get there, but that's what occurred to me. Okay.